Most major river systems operate on a predictable cycle. They collect water from high elevations and carry it across continents until they finally empty into the ocean. But in western Rajasthan, a massive waterway ignores this global rule. The Luni River carves a 500-kilometer path through the desert, yet it never reaches the sea. Instead of an oceanic outlet, the river simply runs out of momentum. It bleeds into the Rann of Kutch, a vast white salt plain where the water evaporates and vanishes into the desert floor. This environment forces a radical chemical shift. The water begins as clean, fresh mountain runoff, but as it travels downstream, the high salt content in the desert soil dissolves into the channel, turning the lower reaches entirely saline. Because there is no outlet to the ocean, the ecological rules for this region are completely rewritten. Whatever enters this river system stays here, trapped within a physical desert boundary. Despite its harsh chemistry, the Luni and its tributary, the Jawai, form the primary lifeline for the Thar Desert. Millions of people depend on this basin for their survival. During the monsoon, farmers rely on the brief influx of fresh water to irrigate these dry, dusty fields, charging the groundwater tables enough to sustain crops through the year. This basin also supports a fragile biodiversity hotspot. The rocky granite hills surrounding the Jawai tributary provide a vital habitat for apex predators like leopards, which live alongside local shepherd communities. The survival of both the local economy and this wildlife depends on a specific balance. The natural chemistry of this closed-loop river must remain undisturbed to keep the region habitable. The Luni begins at an elevation of 772 meters in the Naga Hills of the Aravalli Range. At this height, the rocky, green-speckled mountain ridge yields pure, fresh water. The water stays fresh for the first 100 kilometers. But as the channel passes the town of Balotra, it cuts through ancient, salt-rich desert soils, absorbing the minerals that turn the river brackish. This is an endorheic, or inland, drainage system. Liquid only escapes through upward evaporation, leaving physical matter, like salt, behind. Over millennia, the ecosystem adapted. Local soil structures slowly disperse the minerals, maintaining a stable equilibrium. But this creates a massive geographic vulnerability. An endorheic basin acts as a permanent sponge. If you introduce synthetic contaminants, the river has absolutely no way to flush them out. In cities like Jodhpur and Pali, a massive textile and dyeing industry emerged. Thousands of facilities process heavy fabrics using bright orange dyes and complex synthetic chemicals. By law, factories are required to use treatment plants. Instead, many facilities bypass the process entirely, discharging raw industrial waste directly into the environment to avoid costs. The result is visible and toxic. The Bandi tributary is now locally called the Chemical River, choked with white foam, while nearby ponds have turned a neon pink. This diagram shows how the endorheic trap snaps shut. While water evaporates, heavy metals and dyes sink downward, infecting the blue groundwater reservoirs. The toxicity spreads, poisoning rural drinking wells and turning agricultural roots brown, sterilizing the soil. Human industry injected permanent toxins into a geographical vault. In a normal river, these chemicals would eventually dilute into the ocean. Here, they are locked in the soil forever. In August 2026, the Supreme Court of India launched an intervention that effectively bypassed the state's existing environmental oversight to address the basin's collapse. The court issued an immediate injunction halting the Konkani industrial expansion. Surveys revealed that 13 hectares of the proposed factory sites were located inside a high flood zone, where industrial waste would inevitably seep into the river channel. To enforce this, the court ordered the creation of a dedicated river commission and SIT investigation to target the bureaucratic corruption that allowed the dumping to continue for decades. The mandate applied strict criminal liability under the Bharatiya Nyaya Sanhita, shifting the penalty for bypassing treatment plants from administrative fines to mandatory prison sentences for owners. The SIT investigation found local regulatory bodies actively working with industry owners to falsify pollution data. By appointing a judicial river commission, the court removed the basin's future from the hands of the agencies that had allowed its destruction. This judicial mandate is more than a legal punishment. It is a forced compliance with the physical laws of geography. For decades, the industrial sector operated as if rivers were open sewers, washing away waste. But a closed inland drainage system possesses no such capability. The dyes and metals trapped in the Luni Basin will not wash away with the next rain. They will require decades of scientific remediation to carefully extract from the soil. If industrial expansion continues to ignore the physical constraints of a closed-loop basin, the accumulated toxicity will eventually render the landscape uninhabitable.